I'm Danny Zilio, and I'm here to talk about the CAS Innovation Impact Project on the XML Index Advisor for DB2, Linux, Unix, and Windows. Various people on the project were from the Toronto Lab and the University of Waterloo, including Peter, Wolfgang, Callisto, Iman, and Ashra. The problem that we were solving is related to the fact that most database vendors, including IBM DB2 Pure XML, offer storage and access of XML documents using xQuery SQL XML statements. As part of these offerings, XML indexes were introduced to allow for efficient access to data for these statements. And until now, the selection of these XML indexes have been done manually by the users, and they were selected manually in such that the user wanted to provide the best workload performance within a disk space constraint. This manual selection presents a high overhead in database administration for most database vendors, including DB2 Pure XML, and the XML index selection problem in general has been shown to be an NP hard problem. So as a result of this project, an XML Index Advisor was developed and is now publicly available on the IBM AlphaWorks website. This advisor takes as input a set of queries, basically a workload of SQL XML statements, xQuery statements, insert, update, and delete statements, as well as regular SQL statements. The other input is the disk space constraint, and it takes into account the system and database configuration that are currently being used by DB2. The output is a set of XML indexes that lead to the best workload performance that fit within the specified disk. So here we show the overall Index Advisor architecture. Conceptually, the advisor is an application that makes use of the DB2 optimizers, and the way it makes use of it is it uses special hooks called explain modes in order to compile queries that are then generating virtual indexes under the covers in the optimizer, and generates query plans using those virtual indexes, determines the best query plans and cost of those query plans using those indexes, virtual indexes including existing indexes, and outputs that cost and information regarding which indexes were actually used. So let me go through a synopsis of how the advisor actually works. Initially, what we do is we determine the basic set of XPaths that are indexable within the workload by compiling each query one at a time using a special explain mode called recommend XML indexes explain mode. Under the covers, the optimizer extracts those indexable XPaths and packages them up as basic indexes and throws them back to the advisor through a special explain table. The advisor reads those in, creates that set as the basic index set, then goes through a candidate generalization where it merges those index sets, the XPaths, together in order to come up with index candidates that include asterisks. So for example, one basic set may be /A/B, another index candidate, basic index candidate may be /A/C, and a generalization would be /A/*. So this expanded index set is then input into a combinatorial algorithm called the configuration enumeration, which effectively takes subset of indexes, throws it to the optimizer through a special explain table, and compiles queries with a special explain mode called evaluate XML indexes. That explain mode, when compiling a query, will read in that subset of indexes and create virtual indexes under the covers. It will then compile the queries using those virtual indexes and compete them with existing indexes, and the optimizer will come up with the best query plan with that set and return that chosen index set back to the advisor along with the cost of the queries. So overall, we'll compile the workload for each index set and come up with a cost, and the combinatorial algorithm will determine the best index set that will fit within the disk space constraint. Best meaning the one that comes up with the least cost, and we'll output that recommended index configuration along with the disk space used by the whole index set. The impact to the product for IBM DB2 Pure XML is that we now have developed the Index Advisor, which is now publicly available to customers. And this advisor is executable on any of the platforms that Pure XML executes. It significantly reduces the time required in developing and maintaining physical XML database design. And the indexes recommended by the advisor, because we use the query optimizer, is guaranteed to actually be used by the workload running with that index set. Besides providing the indexes, the advisor provides a set of useful statistics, including the index sizes and the workload performance improvement. And now we're going to show you the demo of the advisor.
XML Index Advisor is a Java application that comes in the form of a jar file. It requires minimum 2 parameters to run. First one being the database name, second one a workload file. Advisor begins its recommendation by extracting XML patterns from a workload file. In this case, 6 XML patterns were extracted from a workload. Advisor then collects database characteristics and sets the default disk constraint if one was not specified by the user. Following the evaluation, Advisor provides you with the list of the index recommendations, which ones you can see over here on the screen. In this case, 3 indexes have been recommended for this workload. Advisor then also gives you evaluation summary, which states initial workload cost, final estimate workload cost if all the indexes were implemented, and final configuration index size. Creating one of those indexes in a database is as simple as highlighting it and pasting it into your control center. You paste the index in, select the Run button, and now that the index is ready to use by the DB2. Advisor can also be run with the -C option, which checks your database for syntactically different and semantically the same existing XML indexes. For that, we don't have to use the workload file. However, we specify the -C option. To test this feature, we'll create 2 syntactically different yet semantically the same XML indexes. First index, index 1, with a namespace Our Book Club and a prefix NS1. And then index 2 with the same namespace URL, Our Book Club, however different prefix of NS2. Now let's see if our advisor will see those indexes as the same. Advisor runs, checks for duplicates, and checks the indexes on a schema name, table name, data type, and an XPath. In these cases, picks up index 1 and index 2 as the same. This demo showcased only 2 functionalities of XML Index Advisor. Advisor comes with a variety of different features and can be downloaded from IBM AlphaWorks website for a trial.